This video is on distinguishing between ionic and covalent compounds. So, how to tell the difference and how to identify them and then how to name or write formulas, kind of just reviewing the whole big thing. So, to review, to fulfill the octet rule, atoms can do one of two things. They can either gain or lose electrons to form ions, right? This is how the ionic bonds are formed, or they can share those electrons to make covalent molecules. Okay, so in the covalent compounds, or covalent molecules, I sometimes call them, there is a sharing of electrons. This is between multiple nonmetals. This usually forms molecules. That's why I often refer to them as covalent molecules. And they'll have a molecular formula, something like the one drawn here, where lines can show shared electrons, and we can also write out their formulas. In an ionic compound, there's oppositely charged ions. So there's cations and anions. They don't form molecules per se. They have formula units or empirical formulas, like NaCl. If we have the empirical formula NaCl, we mean that there's this repeating array of NaCl, 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 and that every sodium is surrounded by chlorine atoms, and so on. Okay, so to identify a compound as ionic, first just find the cation, the positive cation. If there's no cation, it's probably covalent. What's a cation going to look like? Well, that's either going to be starting with a metal cation, or the only polyatomic cation we had was ammonium. And reminder that that was NH4+. So we're looking for, does it start with a metal or NH4+? That's how we'd identify it as ionic. Okay, so practice. Circle only the compounds below that are covalent. So these covalent ones don't start with a metal and they don't start with ammonium. So KNO3, this is potassium nitrate. Potassium's a metal. That's not covalent because it starts with a metal. CH3OH. Well, carbon, hydrogen, and oxygen are all nonmetals. Don't let hydrogen throw you off. Remember, it's a nonmetal over there in a metals world. So this one is covalent. NH4OH. Now you might go nitrogen nonmetal, hydrogen nonmetal, oxygen nonmetal, more hydrogen nonmetal, all nonmetal covalent. But what you need to recognize is that NH4 is actually ammonium, so that doesn't count. It's not covalent. Here we have Na2SO4, sodium sulfate. Well, sodium's a metal, so it's not covalent. HCl, hydrogen's a nonmetal, chlorine's a nonmetal. That works. That would be considered covalent. And then we have NH3. Nitrogen's a nonmetal, hydrogen's a nonmetal, and this is not the same as NH4+. This is the neutral compound, ammonia. So it's good to differentiate between those here. This is the neutral compound, ammonia. It's covalent, versus ammonium is the ion NH4+. So that's good to distinguish those. Okay, so the ones that were ionic started with metals like sodium or potassium, or they started with ammonium, NH4+. Basically everything else is covalent. Okay, so let's do some practice. Let's identify these as ionic or covalent and name each one. This is a great place to pause and try them yourself. Okay, MgF2. Well, Mg is a metal. I'm just going to put an M above it for metal. That would make this one ionic. Let's just go down and do that part. P2O4. Well, phosphorus is a non-metal, so this is going to be covalent. FeNO33. Well, iron is a metal, so this one's ionic. SCl6. Well, sulfur is a non-metal, so this is covalent. F2. Well, F itself is a nonmetal, so F bonded to another F by covalent bonds, just like H is bond to H to make diatomic hydrogen with covalent bonds. K3P. K, or potassium, is a metal, so that's ionic. I could have put an N for non-metal too. Fluorine's a non-metal. Okay, MgF2. Well, we always just name the metal magnesium. Magnesium doesn't need a Roman numeral because it's in the 2A, or the alkaline earth metals. And then fluorine gets changed to fluoride. IDE ending on there. Okay, P2O4. Well, that's covalent. Since it's covalent, we need prefixes. So 2 of the P's is diphosphorus. And phosphorus gives me trouble at some point. I think I may have made a mistake at somewhere along the line in these videos. Just US. Trying to clear that up here. 4 oxygens would be tetra or tetroxide. Our list of rules said to drop the A before the vowel, so we just go with tetroxide after we drop the A. So we got diphosphorus tetroxide. Okay, we've got iron, but here's the thing, iron's not alkali or alkaline earth, it's not the 1 or the 2A, and so iron can have more than one charge. We better figure out what the charge is when it's with NO3. NO3 was nitrate. Okay, here's the thing, a nitrate, let's write it up here, is just a -1 charge, and there are 3 of those. So we have 3 negative charges. That really means our iron has to be a 3+ to balance that out. So we'll need iron Roman numeral 3, or iron 3 nitrate. Okay, SCl6, now it's covalent, so it's going to need prefixes. It's tempting to put mono sulfur because there's only 1 sulfur, but we drop mono at the beginning. No mono at the very beginning, so it's just sulfur, and then 6 is hexa, and we can leave the A here because it's going to be followed by a consonant. Hexachloride. F2, well, that's just diatomic fluorine. Like, that's just how the element fluorine likes to be. Good practice spelling it, T-U-O. But that's it, it's just the element fluorine. And then K3P. Now, it might be tempting to be like tripotassium here or something. But remember, when they're ionic, we never did any prefixes. Prefixes, like hex, are just for covalent. Like di, they're just for covalent. We don't use prefixes for ionic, so we just say potassium, and then phosphorus is phosphide. So it can be tempting once you learn those prefixes to want to throw them around everywhere, but prefixes are only for covalent. We've got our hands full with ionic. We might have to have Roman numerals on that transition metal. We have a lot of polyatomic ions, so we have enough to remember there as it is. Okay, so that concludes our practice here.